Hello, in this video we are talking about section 7.1, which is beginning our discussion of applications of integrals in chapter 7. And in 7.1 we're talking about area between curves. We've already developed in this lecture the formula for an area between two curves that are written in terms of x, but sometimes that's not very convenient, or sometimes it gives us integrals that we can't evaluate. So it's important to be able to find the area between two curves that's written in terms of y as well. So this exercise, which you really should try to do on your own before watching this video, asks you to see if you can come up with two formulas for the area that's described above. So this area is the area between the function f of y and g of y from y equals c to y equals d, where the graph of f of y lies to the right of the graph of g of y on this interval from c to d. So first we're going to come up with a symbolic formula. So this is something in terms of f, g, c, and d and an integral symbol. But to help us remember that, we'd also like to come up with something a little bit easier to remember, like when we have a function in terms of x where it said top and minus bottom. So the hint is, if you're stuck, draw a graphical example to help you. So I'm going to go ahead and start off there with drawing a sketch of the region. So we have something like x equals f of y and x equals g of y. And f of y lies to the right of the graph of g of y. So this would be something like, let's say we have x equals f of y, and, oops, let me use a different color. In fact, let me use a different color for that as well. So we have something like x equals f of y, and x equals g of y. Let's say that y equals c is here, and y equals d is here. So the region that we are wanting to find the area of is this region in between the curves. Now in this case, we could take our functions and rearrange them, solve for y, and I'm sorry, I realized I just accidentally wrote an x here when I should have a y. Okay, so in this case, with the curves that we've drawn, they are actually simple enough. We would be able to rearrange these to solve for y. But let's say that we don't feel like doing that. Instead, we want to find the area of this region by integrating in terms of y. So first off, we need to integrate. We need to have some bounds of integration. These are going to be the c and d values. Our lower bound is always the smaller value that we have, so that's going to be c. The upper bound is going to be the larger value, which is d. Now we also want to make sure that we have a positive area, so we need to have a subtraction of our functions, but the function that comes first is the one that has larger values. Now these are x values. The function values are x values now. So the larger values are the ones that are farther to the right. So this means that we are going to want f of y first, and then minus g of y, and we'll integrate with respect to y. So our formula is the integral from c to d of f of y minus g of y dy. But to make it a little bit easier to remember, we want the larger values, so those are farther to the right. So we're going to have right minus left. And there we go. This will allow us to be able to find the area between curves with integrating in terms of y.